So their final term project was to design a robot which had to be no bigger than a 4 by 4 by 4 inch volume to navigate this maze which is behind me. They have to have an output display on the robot that indicate what's going on. They need to have some kind of manual data input. There needs to be some automatic sensor input on the robot so we can automatically figure out what's going on. There needs to be some actuators and hardware on the robot to take actions and navigate it through the course. And of course, there's some logic processing and control, which is embedded in the microprocessor on the robot. There are penalties for collisions with the obstacles or the walls, and the lowest time wins.
All right, let's do this.
Some of the basic major challenges they have to overcome is pretty much just programming the entire thing and having all the sensors communicating to a microprocessor, which relays information to the drive motors and the wheels so it can navigate through the course. Each sensor is different. Like some sensors read out voltage, others depend on resistances. So you need to know the properties of each sensor and how the microcontroller reads that. Right now they're primarily using proximity sensors, which tells the robot how far it is from a wall or an obstacle, so they know when to stop. They're also using some encoders for the wheels. So the encoder just counts every time the wheel rotates, so they know that every time the wheel rotates, they can figure out distance that way.
What it does is it sends an infrared wave out, it hits the wall, and it measures the amount of time it takes to get back to the sensor. Using that knowledge, it gives you the exact distance that you are away from the wall.
This final project builds throughout the course. We have labs going through the entire class which teach them all the skills that they need in order to accomplish this task.